I gave DeepSeek, KIMI K3, and Claude Opus the exact same 10 coding tasks. Same prompts, same repo, 0 hints. One of them nailed every task. One of them quietly cracked under pressure. And the cheapest one might actually be the most expensive by the end of this video. Right now, thousands of teams are letting AI models write, review, and ship production code. Not as an experiment, but as part of the actual workflow. And most of them are picking a model the same way you'd pick a phone plan, by the price on the page. DeepSeek costs a fraction of a cent per call. Claude costs 20 times more. On paper, that's not even a decision. But price per token was never the real question. The real question is, what does it cost you when the model gets it wrong? A cheap model that quietly breaks your checkout flow isn't cheap anymore. So I stopped reading spec sheets and just ran the test myself. Here's the setup. 10 real-world coding tasks, spanning 3 difficulty tiers, from a 5-minute bug fix up to a genuine memory leak that would pull a senior engineer into a war room. Every model received the identical prompt, the identical starting repo, and 0 hints about what was wrong. I scored every attempt one of 3 ways: a pass, meaning it shipped clean; a partial, meaning it technically ran but needed follow-up work before you'd trust it in production; or a fail. I timed every single run with a stopwatch, and I calculated the exact cost of every attempt using each provider's official, published API pricing, and critically, first attempt only. No retries, no cherry-picking, exactly how a real engineering team would actually use these tools. Before the results, a few honest caveats. This was 1 run per task, not an average of 10. Frontier models are non-deterministic. Run it again, and a few of these could flip. The cost model uses each provider's real, published pricing. But the engineering time assumption, 20 minutes at $75 an hour, is mine, not theirs. Your repo, your team, and your actual failure rate will vary. This isn't a peer-reviewed study. It's one engineer's best attempt at answering a question spreadsheets can't. What does cheap actually cost you? Round 1. The fundamentals. Task 1. Fix a failing unit test caused by a classic off-by-1 bug. Task 2. Add proper input validation to a sign-up API endpoint. Task 3. Build a full CRUD endpoint straight from a written spec. Nothing exotic. The kind of tickets that fill up every single sprint. And all 3 models passed all 3 tasks, full marks across the board. But look past the check marks, at the clock and the price tag. DeepSeek finished in roughly a third of the time Claude needed, for about 1/10 of a cent per task. On easy, well-defined work, the expensive model isn't buying you anything extra at all. Round 2 is where the cracks start to show. Task 4. Refactor a 400-line God class, the kind of file every codebase has at least one of, into clean, testable modules. Claude finished fastest, in 47 seconds, and threw in regression tests nobody even asked for. KIMI K3 wasn't far behind, landing a clean split at 55 seconds. DeepSeek took the longest of the 3, at 61 seconds, and still got it wrong. It did split the class into 3 files, but it left a circular import between 2 of them. It compiles. It even passes the existing test suite, but it's a landmine sitting in your codebase, waiting for the next engineer who touches it to find out the hard way. Task 5. Fix an N+1 query that's been quietly dragging down a dashboard. All 3 models nailed it. Claude edging out the field by a few seconds, but nothing dramatic. Task 6 is where it gets more interesting. Build a React component straight from a design spec, matching spacing, matching every interactive state. KIMI and Claude both delivered clean, pixel-accurate components. DeepSeek's version technically worked. The component rendered, the logic was sound, but the spacing was off, and 2 of the 4 hover states were missing entirely. Not broken, just not something you'd ship to a designer without a second pass. Now, the task that actually separates these models. Task 7. Find and fix a memory leak in a live WebSocket service, the kind of bug that shows up 2 weeks after launch as a slow, creeping crash nobody can explain. This is the job senior engineers get pulled into war rooms for. Claude found it first, an event listener that never got cleaned up on client disconnect. It fixed the leak and passed a 10-minute soak test completely clean, in 52 seconds. KIMI K3 found the exact same root cause, but its fix broke the reconnect logic on the way out, a partial pass that needed a human to finish the job. And DeepSeek, the model that had crushed every fast, cheap task up to this point, patched the symptom instead of the cause. Memory usage kept climbing straight through the soak test. On the one task that actually mattered for a real production system, the cheapest model failed outright. The home stretch. Task 8. A sliding window rate limiter. Task 9. Migrating a JavaScript file to fully typed TypeScript. Task 10. a command line tool with argument parsing and tests. Claude and KIMI K3 passed all three cleanly, no notes. DeepSeek passed the rate limiter and the TypeScript migration without issue, but its CLI tool shipped without the argument validation the spec explicitly called out, another partial. Add it all up across all 10 tasks, and the final tally reads, DeepSeek, 7.5 out of 10. KIMI K3, 9.5 out of 10. Claude Opus, a perfect 10 for 10. Here's the full scoreboard. Pass rate, DeepSeek at 75%, KIMI K3 at 95%, Claude at a perfect 100. Average time per task, and this one surprised me. Claude is actually the fastest model overall, at just 36 seconds a task on average. Being smarter doesn't just mean fewer mistakes, it means less backtracking, fewer wasted tool calls, less time spent second-guessing itself. And average cost per task, DeepSeek at just over a penny, KIMI K3 at 8 cents, Claude at 11 cents. Looking at these three numbers side by side, it seems like an easy call. Case closed, except that's not actually the number that matters for your business. Stick with me. Here's the number that actually matters. Cost per successfully completed task. Not cost per attempt, cost per task you can actually ship without touching it again. Take DeepSeek's total spend across all 10 tasks, divide it by the 7.5 it actually got right, and its real cost per success nearly doubles, to almost 2 cents. Do the same math for KIMI K3, and its cost climbs to 9 cents. Claude barely moves at all, because it didn't waste a single attempt. Every dollar it spent on a task that actually shipped. Cheap only stays cheap if it works. So let's actually answer the question, is the cheap model cheap? It depends entirely on your volume. Stage 1. You're a solo developer, shipping maybe 50 AI-assisted tasks a month. Raw compute cost, DeepSeek, about 70 cents, KIMI, $4, Claude, $5.30. At this scale, the difference is coffee money. Go with whatever you like best, it genuinely does not matter. Stage 2. You're a 10-person startup, shipping 500 tasks a month. Raw compute, DeepSeek, about $7, KIMI, $41, Claude, $53. Still pocket change for any real company. If a task fails, you catch it in code review and move on. Stage 3 is where it changes everything. You're a team that's gone all in on AI-assisted development, 10,000 tasks a month, agents running across every ticket and pull request. Raw compute, DeepSeek, $139. KIMI, $820. Claude, just over 1,000. Still looks like DeepSeek wins, right? Now add the line nobody puts on a pricing page. Every failed or partial task needs a senior engineer to catch it and fix it. Call it 20 minutes of their time, at $75 an hour. At 10,000 tasks a month, DeepSeek's failure rate alone adds over $62,000 in engineering time. KIMI adds around $12,500, Claude adds $0. At scale, the cheap model just became the most expensive line item in the entire engineering budget. Honestly, the biggest surprise wasn't that Claude won. It's that Claude was also the fastest, on average. Being right the first time turned out to save more time than being cheap per call ever could. And the real shock, DeepSeek is a genuinely excellent model for 80% of real engineering work. It only fell apart on the 10% that actually keeps you up at night. Knowing which 10% that is, for your own codebase, is the whole game. So, is it worth it for your business? It depends entirely on what a mistake actually costs you. If you're a solo dev prototyping, automating internal scripts, or shipping a side project, DeepSeek's price is almost unbeatable. A wrong answer just costs you a 30-second rerun, not a review. If you care about open weight control, data sovereignty, or you're planning to self-host on your own infrastructure, KIMI K3 gives you a genuinely capable model, and the economics change again the moment you own the hardware, instead of renting it by the token. And if you're running a real engineering team, at real volume, where one bad merge costs more than 100 good API calls put together, Claude Opus isn't the expensive option on the table. Run the actual numbers, like we just did, and it's the cheapest one there. That's the real cost of AI-assisted coding, and it was never about the price per token. It's about the price per mistake, multiplied by how many mistakes you're willing to tolerate. All 10 tasks, every number, and the full cost model are breaking down in the description below. If this saved you from picking the wrong model, follow for more of these breakdowns.